This conference will now be recorded.
And working a little bit from home. Is anyone else here?
Yeah, Alfredo's here, and Terry's here, and AJ is here. Royal Command Performance.
What's that?
Royal Command Performance.
Okay, it's right at 12 o'clock, and I think just because we have 6 speakers, and we definitely want to allow plenty of time for them to get their talks in, so I want to get going here. Just a reminder, if you are not talking, if you're not a speaker, please mute. Appreciate that very much. And like to just, we are being recorded. This will be recorded, and this will be available after the session, after a few days. But anyhow, I want to welcome everybody to our 10th webinar, but more importantly, first one in 2023, and actually the first one since we all met, or most of us met during the workshop back in September. So kind of excited to get the webinar series going again. And really, this webinar is really sort of a follow-on on some of the recommendations from that workshop, and I'll talk about that a little bit more. Next slide, please. So our agenda for today, I'll just give a few quick administrative updates, and then we'll get to our panel members, which you can see we have a great, I'll introduce them later, but a great list of panel members. And you see the kind of the theme is really built on what Hank, when he briefed at the workshop, talking about, having folks share and using kind of the theme, what's in my garage, what's in my glider garage, but also what's not, and what the type of support people would like to have, or capabilities they have that they don't have, and could reach out to people. So we'll talk more about that, and then we'll do a quick wrap up. Next slide. So just a reminder, this is our steering committee. We'll actually be meeting next week. On the next slide, I'll talk about this a little bit. Just bottom line is that our charter stated that the steering committee members would have 2-year stints, and we're actually at 3 years with the pandemic. So in the very near, we will be putting calls out for nominations for the steering committee as we reach that. Really, it was like I said, the charter's 2 years, but we're at 3 years, and so we'll be putting out nominations for people who would like to be on the steering committee, and that will probably come out in about a month or so. Next slide. So the first bullet I mentioned, one big what came up in the workshop was, having an industry panel that be a part of UG2, and then that industry panel being able to nominate a representative to be on the steering committee. So we'll be pushing forward with that. And for folks, just a reminder here that the next bullet is that the full glider workshop report is out, and there's 2 links here that are available. I think Rudy put it up in the chat session as well, but these are links to get to the report if you haven't yet, and then also to get to the full briefs that were presented as well. The link is provided there as well. Any quick questions on that at all from anybody? Okay, good. We'll move into the fun part and the meat of our webinar today. So like I mentioned, Hank, a lot of the comments that came after the workshop was to definitely put a little bit, have more of an operational sort of twist, as well as the importance of the science talks as well. So in the next two webinar series, that's going to be our focus. And Hank, when he briefed at the workshop, brought up, it would be great to have a series of brief of people going around both regionally and capability wise of briefing what they have at their facility and what they don't have and where they may need help. So that's here. You can see our list of briefers. And without further ado, I'm going to start off with Hank Statsewich from the College of Fisheries and Ocean Science at the University of Alaska in Fairbanks. And he'll kick it off. And basically, they'll be speaking for about 8 to 9 minutes, and we'll have about 2 minutes if you want to drop a question in the chat. And if not, we'll capture these questions and probably push them into the Slack channel later on for folks to answer. But go ahead, Hank. If you're ready, take it away, please. See your slides.
Okay. Yeah, okay, great. I just need to figure out how to use GoToMeeting. Hey, thanks for the introduction, Bill. I appreciate that. Okay, so let's see here, a little technical difficulty. If I go full screen, can you see that, Bill?
Yes.
Yes.
I'm pretty sure everybody else can see your full screen. Very good. Thanks.
Great. Yeah, so what's in my garage? I think that this is a really cool topic. I'm glad that I get the opportunity to sort of show off what we have in our garage at the University of Alaska-Fairbanks. When I sort of started thinking about this, I realized that the garages, just traditionally, at least in the United States, have been this place of innovation. And it's not surprising that some of the biggest corporations in the world right now all started in people's garages. So, I did a little bit of surfing the web, and I realized that Bill Gates, Microsoft had started up in a garage, Apple, Google, Amazon, Harley Davidson, Disney, Mattel, they all started in this garage. And so, that's kind of where the garage is a place where innovation takes place. And it's important that as glider operators, glider users, as we undertake this, these amazing pieces of technology, that we sort of have a good idea on how to build these things and how to utilize the space so that innovation can take place. And so I thought a good place to start would be my garage layout, my laboratory, basically. It's about a 1,200 square foot space, and it's broken up into 3 distinct work areas. I've got a region on the floor that we call the ballasting area. It's got a large dock server workspace, 2 glider benches, a half-ton pedestal crane that can reach out across the glider benches, and it's got a winch that's on, or hoist, I should say, that's mounted on an I-beam so it can slide back and forth. So it's really designed such that one person can pick the gliders up out of the shipping crate, put it on the bench, open and close it multiple times, get it into the ballast tank as many times as you need to make sure that it's perfectly ballasted, that the pitch and the roll, H moments are all adjusted, and help themselves to an espresso if they need it. Lots of tools, lots of tool carts, lots of different shelving for spare parts and small pieces, fuses, wiring harnesses, so on and so forth. And then we've got this assembly area on the left side, and the assembly area has also got a couple glider benches that are a nice ergonomic height that you can open and close the vehicles, rolling workbenches, lots of spare parts, places for batteries, and another dock server over there. Those are local dock servers, not really connected to the internet, just so that you can talk to the vehicles while they're sitting on the bench, whether in Pico DOS or in Glider DOS. Important soldering bench, if you actually have to do any board level soldering or cable building or RS-232 comm wires, you got to have a dedicated place where that sort of work can take place. And then a staging area. And the staging area is where as a glider comes in from the field or is getting ready to go out to the field, you can stack up the glider crates and get them ready for shipping and take care of the hazmat paperwork and all the labeling and so on and so forth. So our saltwater ballast tank is about 10 feet long, 5 feet wide, and 4.5 feet deep. I find that that's a really effective space for being able to test the H moments with the pitch battery. The pedestal crane, again, I said it's a 1/2 ton. And yeah, that's kind of the layout. And this is what it looks like. You can see the pedestal crane there with the 1/2 ton hoist. Our ballast tank, we keep it covered. It's a saltwater tank. Underneath the workbenches, we've got kind of dedicated space for the vacuum pumps and tool storage so that you're just, kind of quickly and efficiently able to pull a vacuum when you need, and you're not hunting for the standard tools to take these things apart, put them back together. In the background, you can see lots of those rolling tool carts with benchtop space so that if you're working on something that you need to spread out a bit, like on the bottom right photograph, where we're testing for electrical noise with an oscilloscope, you can just roll a bench over and quickly and efficiently troubleshoot something or make modifications as needed. And that's the top right there is the ballast tank with a turbulence profiler mounted on the nose of a Slocum. You can see that there's plenty of space on the inside the ballast tank for a full length glider, even if you were to put a few extra accoutrements like an extended battery bay, which this one has on it currently. And then in our assembly area, you'll see that there are both gliders of the yellow flavor and of the pink flavor now. We have some small parts bins, workbench, all the storage that I was talking about, shelving storage. On the right side, you can see the soldering workstation, heat guns, solder, all the fuses and spare parts and electrical tape and heat shrink, all that sort of stuff. And the staging area, again, is just it's kind of a dedicated floor space because the glider crates are kind of enormous and you need a place to put them while you're getting them ready for going out into the field. Now, if you're a new user, you're probably thinking, where can I find all this stuff? If you haven't been, in the industry very long, it can be kind of a daunting process. But places like McMaster Carr, if you start looking through their online catalogs, they have everything that you could possibly imagine to set up a new glider lab. This pedestal crane is the exact same one that we bought, had it shipped all the way up to Alaska, talked to our facilities maintenance folks, bolted it down to the floor, installed the 1/2 ton hoist on it. And, the total price, including shipping with the hoist, was maybe about $5,000. The workbenches that I have in my shop, I bought years and years ago at a box store, Sam's Club, where they had just the perfect height, the perfect work surface for putting these things together. I know that places like Costco and Home Depot, they all sort of sell similar products that are fairly inexpensive, but perfect for the task at hand. My ballast tank is a indoor swimming pool. It's got a water filter. I think we bought it through a company called FitMax. I think Intex, a few other companies sell the same ballast tank. It is very effective. We've had it almost 10 years now. We bought several more that we fold up and then ship out to different locations if we need to do testing in a remote facility. And then all the different electronic suppliers like Newark, DigiKey, and Mauser supply the very specialized tools and components that you might need to keep your gliders running. So things like fuses and Molex crimp tools and connectors and all the different wiring harnesses. Lots and lots and lots of time and effort is sometimes spent to try and figure out what is the connector that I need to replace that got ripped off during a ballasting exercise, and now we're down 3 or 4 days while we kind of wait for these things to come back to us. And luckily, they all ship overnight and are really good about turning things around pretty quickly. Like I said before, our ballast tank is a saltwater tank, and I buy these 5-gallon buckets full of instant ocean sea salt, and I attempt to match the density of our target ocean that we're flying in, and haven't had any surprises so far. At one point in time, we used to have 2 ballast tanks in our lab. One was freshwater and one was saltwater because we had a few limnologists that were interested in doing some freshwater work, but we've since gotten rid of the freshwater tank because we just didn't have the demand for it. So what's missing? Right now, I think one of the big things, we haven't had any failures due to O-rings yet. We've had several leaks over the years from different components, but I'd really like to see our lab expand to have a climate-controlled clean room. I think that working on these electronics, getting dust in there, particularly the more sensitive echo sounders, it's just not, we're not setting ourselves up for success. And so I've been working with a few different companies to kind of design a snap together HEPA filtration, climate controlled clean room. They're fairly expensive, I think on the order of $20,000 to $30,000 to put in our lab. And then the other thing that's missing really is an industrial grade electronic diagnostics center. I don't think that my university really wants to see us build something like this out. We don't currently have any laboratory facilities that are quite industrial grade. But I guess I'm going to have to continue to rely on the manufacturers to provide that capability. And then just to round things out, we actually have one of these things in our garage. But if you know anything about Alaska, it's a pretty enormous state. And I am located directly in the center of the state in Fairbanks. So we have to travel about 400 miles to get to the ocean. So I'm kind of just making a little bit of a tongue-in-cheek joke here. What's missing is the ocean, but we do have a marine field station, and down at our marine field station, we've got several sizes of and classes of vessels. One of my favorites is just this large Zodiac that you can fit 2 gliders in. It's got a nice center console that we can easily get out to some of the fjords and deep basins in the Gulf of Alaska to deploy and test our gliders as needed. So that's all I have for today. Let's see if I can stop this share. And I'll take questions if anyone has any.
So your facility down by the ocean, Hank, the lab is back at the university. Is that correct?
The lab's in Fairbanks, and
It's in
our
Fairbanks.
marine field station is in a city called Seward, which is about
Okay.
400 miles away. Yeah, so every time we want to do kind of extensive testing, we essentially do all the ballasting in our lab and then prep things to get shipped down to the field station.
Okay.
Once we're down at the field station, we have a smaller lab. It's not very permanent, but it's a benchtop space and a ballast tank essentially. But we don't have the overhead hoist and the crane, so it's more it's not perfectly set up at the moment.
Perfect. Great. Like to visit it.
The field station is a great place to visit. I want to host a training operation there at some point in time.
That'd be awesome. Thank you very, very much. Any other? I don't see. Yeah, great lab. Really
Thanks.
appreciate that. Okay, well, I don't see any questions in the chat, so we'll move on to our next briefer, and that's Adam Comeau from Coastal Environmental Observation Technology and Research from Dalhousie University. So, Adam, I'll let you take it away. Thank you.
Thank you very much. Can you see my full screen? Do you see the notes or anything?
Yes. I don't see the notes. I see your slide.
Okay, perfect. Well, I'll get started. Well, thanks everybody. Thanks for inviting me. Yeah, so I represent the CEOTR glider team. I manage the group. We're an organization that's funded by a whole bunch of institutions that you can see below, and we do glider missions for researchers. But what's in our shop? We've got people. We've got a whole bunch of really awesome glider techs. We've got data people and management. Not all these people are dedicated to gliders. They do other technical services for the CEOTR group. But just I felt it was important to mention that there's actually a lot of people in our shop sometimes. And one thing that I'm going to talk about in the shop, you'll see lots of spare parts, kind of like what Hank was saying. Our shop, we do lots of different things. We do passive acoustics, we do lots of zooplankton missions or bioptical oceanography stuff or animal tracking. And we try to make our gliders multi-stakeholder, so we're always changing things around. So I think that kind of drives why our glider shop is what it is. It's because we had to kind of adapt to the constantly changing gliders. So we've got, that's kind of the reasoning behind some of the things that you'll see later on in my talk. And then, just for context, another thing that guided some of our decisions is that we're mostly coastal operations. Most of our deployment and recoveries happen along the coast. And sometimes we will farm out a glider deployment to some trained fishermen or something like that. This gives you an idea of our field boat. We've got a 21-foot Zodiac with a boom and a glider cart on the back. It's been pretty handy for us to rip out, 20 miles offshore to put a glider in the water or to pick it up. It's been pretty fun. This is just, showing that sometimes we get fishermen to deploy, when we've got to go further outshore and get bigger boats and stuff like that. But getting back to our shop, we've got a little bit less space than Hank. We've got 375 square feet dedicated to slocum prep. We do have a mezzanine. I'll show you a picture of that. That's almost 300 square foot. It's like a floor and a half. And we also have wave gliders that we prep as well in our shop. We have the same issue with storage in terms of glider crates, those big Pelican crates. So we end up getting some containers, just storage shipping containers outside. Then we put all of our crates in there because we don't have enough square footage to keep them inside. And then we just recently purchased a heated and climate controlled container for, storing excess gliders, during times when they're not used, especially for the wave gliders, because they take up a lot of room. It's worth mentioning that don't take these numbers purely, even though they're small, don't say that, you can, that they're enough. We're constantly overflowing into our neighbors' space. Luckily, they're good neighbors and they don't mind, and they're not always using their space. So that's just a caveat to use with these numbers. So now we getting to some of the images. This is kind of, what we've got. I mentioned we have a mezzanine. So this is just kind of like a half level in our glider shop. It's been really good to store spare parts, boat supplies, the lithium battery cabinet, our server, that kind of stuff. And then underneath the mezzanine, we've got the ballast tank, where you can see here, we've got a electric winch, a hoist system to lift our glider from the ballast tank to one of our tables that we've got alongside. You can see this ballast tank, it's 10 foot, it's a little over 10 feet long. It's filled with seawater. There's a little viewport in there, and that's pretty handy when you have instruments in there. One time it came in handy when we had a CTD pump that was clogged or the impeller wasn't working. You could actually look through the hole and see if there was any little particles flying around in it. It's a seawater tank, and we do have a running water filtration system in it, and we do keep it covered because it gets pretty dusty and grimy if we don't. And just like Hank was showing, I think one of the big things is storage. We've got lots of storage supplies for spare parts, connectors, wires, stiffener rings, pick points, all that kind of stuff. We've got a whole bin dedicated to Molex parts and specialized Molex pins and crimpers, all that kind of stuff. This table on the right-hand side in our shelving system has got lots of ballasting supplies and scales and stuff like that. We've got lots and lots of screws and hardware. Basically, we did the McMaster-Carr route as well, and we just buy one of almost everything that we need. A really handy thing that we got early on was this. If you look on the left image around the right side of it, you can see this little weird series of black things. This is just like a ruler to measure out screw sizes. So it gives you thread count and stuff like that. It's been pretty handy. You can see on the right image here, you've got lots of spares. We got spare science bays. That's been really helpful for us, so that if we need to change up the science sensors to do a new type of mission, we can just swap one in. We've got spare instruments. We've got spare, hull sections of different lengths for going in different water masses. Sometimes when we got to get the glider lighter, because we're putting a heavy echo sounder or something like that, we put in a long hull. Spare stiffener rings, all that kind of stuff. We take advantage of our small space by having some vertical glider storage. This is just a picture of one of our racks here. We can have 4 of our gliders stored like that. They're pretty easy to get a glider in there. You can do it with one person. It's pretty nice. We've got some 3D printers. As you can see, we've got 2 different ones, and we've used them to 3D print little adapters and holders and stuff to either go inside the glider or externally mounted, sometimes in the aft cowling, to hold an optoad or something like that. So far, we've had 3D printed parts go down to 1,000 meters, which is was a big success for us. And we use them also for prototypes before we get, the machinist to make a steel one. We also have a battery storage container. This is pretty handy when we get lithium batteries in. We have a place to put them that's as safe as it can be, I guess, although I wouldn't want to see that filled with fire. But yeah, we put our new batteries and our old batteries in there before we recycle them. Sitting on top of that is just a big server that we've got. This is our shop server, and it's actually hardwired to several free-wave modems, so that anytime we turn a glider on, it connects to SFMC, and we can just use it on any laptop that we've got connected to the same network. It's been really convenient not to have to do the free-wave jungle or whatever. Just going through, we've got some new pick point designs. Feel free to reach out if you're interested. We'd be happy to share these. They've been really handy to use a gaff to recover your glider with. We've designed these end caps as well that have been good to seal up science bays to use for pressure testing. If you're ever swapping a sensor in and out of an EcoPuck port and want to get it pressure tested, you can just slap on a couple of these caps and send it to get pressure tested. Luckily, there's a company just down the road from our shop that does this service for us, so it's been pretty handy. And of course, running a glider shop, you need lots of friends, whether it's the pressure testing company or the local vessel charter companies. They've been great helps. We've got a compass hut. We don't have a compass hut that's basically a non-ferrous metal building that the Bedford Institution of Oceanography made for calibrating compasses that go to the Arctic. And they've let us use it for Slocum gliders, so we've been able to hang them there and do the dance as well. There's lots of local groups that have helped us out, including the Slack group here on the UG Squared. Some of the issues keeping us up at night, just to generate some discussion, maybe in the Slack group afterwards. We've had lots of buoyancy engine leaks, especially with the 200-meter buoyancy engines. Talk to me about that if you've got some as well. Mission aborts, especially with the new STM32 system. Bias resets with persistent gliders that led to some dead gliders in the water. Piloting, of course, keeps us up at night because you always get an abort at night. We've got a new set of regulations that just came through. This is not Slocum glider related, but with our wave gliders. So if anybody's using wave gliders outside of the US, I think, especially in Canada and the UK, feel free to reach out to us. I'd like to chat about how you got around these regs. And one thing that will be keeping me up at night now is the lack of a Canadian flag in our shop, because I see a nice American one in Heck's shop. And I'd just like to finish off with this shopping list. I figured it might be nice to include just as reference material. These are all things and spare parts that we've bought over the years. I've got a running, price list, but it's unofficial, and I think Clara would kill me if I shared it with everybody. But anyway, I think this list would be handy for new users to kind of know what's out there and what you can buy with spare parts, especially if you got year-end money to spend.
Hey, Andrea.
And that's it for me.
And
Thank you.
Perfect. Thanks, Adam. That was awesome. So the pick points that you brought up, are you manufacturing them in your shop, or do you have a third party doing those for you? Or
We've got a third-party company that's right next door to us. They're called Precise Design, and we've worked with them to manufacture the pick points as well. Yeah.
so if somebody wanted one of those,
What's that?
no, I was going to say essentially they are commercially available if somebody wanted one, right? Yep.
Yeah, we can share the design. We can get them made and ship them to you. Yeah.
Okay. Oh, that's awesome. And you mentioned the people, and I really appreciate that, because it takes a lot of folks, anywhere from techs to engineers, and scientists to make this work. And it's amazing, in Hank's brief and yours so far, and I'm sure we'll see in the others, what it takes. You see the science end of it, but it takes a lot in the background to make these things happen. And hopefully early career folks are out there on the webinar and seeing that there's lots of jobs opportunities out there, because it takes a lot to make this happen. So yeah, thanks, Adam. That was super.
No problem.
Quick question, Adam, if you don't mind.
Yeah, go ahead.
So how do I phrase this? So there are operations on gliders that are sort of certified by the manufacturers that users are fully, blessed to do after training. But there are a lot of operations, and you sort of touched on quite a few things that you do that are well outside of the range of maybe acceptable practices. Like the void the warranty type stuff. And we do a lot of those operations in our lab as well. Sometimes I try to keep quiet about what we're actually doing, and I'm wondering, like, how many years did it take before you started to feel comfortable, let's say, swapping out a digifin, or doing this pressure testing on your own science base, swapping out CTDs or any other the science base or EcoPuck components? I'm kind of interested to see how many other users are actually doing this, and if we're all doing it, why aren't we sharing some SOPs? Because it does save a lot of time if we can do that sort of stuff in-house.
Yeah, definitely. I mean, for us, it's been a gradual process. We didn't start off doing that. Even in the first 5 years, I'd say we were really by the book. But then, once we started getting comfortable and understanding what was how to do this stuff and what the O-ring seals were about, we started getting more comfortable with it. And we talked to web research a lot, and of course they have to say it's going to void the warranty in that. But if you've got an old glider, you don't have a warranty on it anyway, so you're not really losing anything. The pressure testing was something that we took really carefully. We got those end caps that we designed in-house. We got the Precise Design, our local manufacturer, to run some engineering specs to do stress tests and stuff like that. It definitely took us a little while to figure out, but we took our time and eventually we got there, and we've been using it. It worked good. We also use those end caps for nose sections as well, so we can actually do pressure testing on, the whole front section or the aft and that too. But it took some while to get there.
Thanks. Yeah, I think Hank brought up a good topic of sharing SOPs as a great, as we move forward. We can either do that through kind of like webinar training sessions or whatever, if folks are comfortable with doing that, of course. So something to think about moving forward as we collaborate. Thanks again. Really appreciate that, Adam. Okay, our next, talkers is Fiona, Elliott, and Ailin Brakstad from the Norwegian National Facility for Ocean Gliders at the University of Bergen. So Fiona and Ailin, please take it away. Thank you.
Cool. Thanks, Bill. Can someone just confirm that you're seeing this?
Yes.
Cool. Okay, so I thought I would just start by giving you a quick overview of our team and then our glider fleet, the areas that we're working in, and also the kind of deployments that we're doing, because this is really going to inform how our workshop or garage is set up. So we're at the University of Bergen in Norway, and our glider facility is called Norgliders. So we're led by Alaska-Fairbanks, and then Ailin Brakstad is 50% technician and then a 50% research role, and then we have myself, who I'm like 100% technical capacity. We've got a rather large group of pilots, I think. So most of us are from the University of Bergen, but we've also got people from the Institute of Marine Research, and which is called IMR, and the Norwegian Polar Institute. And then a couple of other people or groups that are really important to our operations are the science techs, the shipboard science techs that are on IMR research vessels, and our IT engineer, Ida, and the logistical support that we receive. So just to go over our glider fleet, we've got 4 sea gliders. So I believe these were purchased in 2012. They're still operating really well. And then we have some slocums. So the G1s are not really in a seagoing state. And we purchased 5 G3s in 2020. So this was mostly as part of the NORAMSO project, which is looking at water mass transformation in the Nordic seas. So these have installed in them just a seabird pump CTD. Some of them have Onduro optodes. And then we've got a couple of micro riders that we can install on the gliders for specific process studies. So almost all of the slocums are stretch gliders. 3 of them have rechargeable battery packs, and then the rest will just be the 4S battery packs. So here's an overview of the main areas that we're working on. If you look on the Norwegian coastline, we've got 2 kind of permanent, by permanent I mean funded for 5 years, which is as permanent as we get, rechargeable glider sections. So these are serviced 4 times a year when the IMR research cruisers go to the area. And then over on the western side, we have our endurance missions. So these are carried out by stretch slocums or sea gliders, operating anything from 7 months to just over a year. So I think a key aspect of how we're running our lab is that,
relevant to a federal awarded grant. The relevancy is that billions of dollars.
Hey, Landry, could you please mute? Landry, you need to mute. Thank you.
Sorry, I thought that was me for a second. So I was saying there's like a key characteristic of how we run our operations is that almost all of our deployments are happening from large research vessels well offshore, and almost all of the operations are actually carried out by people that are not trained specifically with gliders. So quite often we get assistance from the IMR onboard technicians, and these people are fantastic because they have the right skill set, but they don't have necessarily glider experience. So Ailin and myself, we spend a lot of time writing out detailed procedures and summaries of what they need to be doing. So some of the work is quite technical. I mean, turning around a rechargeable glider, that's an 18-hour process. There's quite a few things to it. So yeah, we spend a lot of time writing these procedures, and we're trying to make them as easy to understand as possible so these people can kind of consume and understand the information as quickly as possible to make their job easier, to make them more willing to collaborate with us. And it also, I mean, this is what keeps our operational costs down, because we cannot send our own technicians off on these 6-week cruises whenever we want to deploy a glider. Okay, so here's a photo of our lab. I took it from the top of our forklift today. So our workshop is based in a facility called the Norwegian Ocean Laboratory. So it's basically a giant storeroom, and there's several different ocean research institutes that are using this space. So our space, as you can see, nothing's really permanent. It's a super flexible area that we can configure as we need. We don't have a huge amount of space. We need more space. Everything that we can have on wheels, we put on wheels. If you look over to the right, that's the ballasting tank. It's a nice big tank. There's an electronic hoist above that. That is key to my everyday operations. I think Hank was referring to that before. I I mean, even 2 people can't really lift a stretch glider. So that's pretty important to me. And then you'll see on top of the hoist, there's like a bar that we can attach scales to for ballasting the glider. So a cool thing about the location of our lab is there's actually several aquaculture labs nearby, and these people are very picky about their seawater sources. So we're able to tap off of their 100-meter source seawater supply. So that actually ends up being very similar to our target locations in the Nordic seas, which definitely simplifies the ballasting process for us, and it gives you a lot of peace of mind when you're going to deploy a glider, especially since we deploy gliders from large research vessels. If you don't have the ballasting down, the operation to recover the glider is like an hour-long process, and you might not be able to redeploy it. Yeah, it sounds like other people do have a ballasting tank in their lab. For us, I mean, it's super convenient. It's also a bit of a hazard having a large water mass in an electronics lab. So really, as soon as we've finished ballasting, it gets drained out into the car park. And then, yeah, when we're filling it up, we just have all of our electronics covered up in case there's any splashes. So this is a couple of shots of various tools that we use. When I'm servicing a glider, I'll generally have it set up on a movable workbench, and then beside that will be like a smaller bench that we can move off the sections onto. In terms of tools, I think it's pretty standard, like for any kind of instrument lab. We've got several, anti-static mats and grounding lines, DC power supplies, soldering irons, multimeters, vacuum pumps, obviously essential. Empty coffee cups all over the place. We do, it's really important in our lab that we document everything that's happening, so we can, I'll be working on a glider for 1 week, and then Ailin will come along and she will be able to pick up the work that I've been doing as well and the problems that I've been having. Down on the bottom, you can see, so we have access to a local vessel. It's called Tobias. So we don't really use this as much as we should, but we do have this option available if we need to do some local testing for problematic gliders, or if we're trying to kind of figure out a new deployment situation. And then you can also see on the left-hand side, there's like a massive rig that we've used in the past for recovering gliders. It's kind of a nightmare, to be honest. It does operate really well, but it takes several hours to set up. So I usually, we're trying to move away from that. And then beside that, we've got several rigs that we use for deploying gliders from research vessels. Field going toolboxes are very much dependent on who is going to the field. If it's a glider tech, we expect them to be able to troubleshoot and fix an awful lot of things at the time. And then for non-glider techs, we really try and minimize the amount of equipment we're giving them, because we don't want to overwhelm them. There's so much new information, and we kind of just accept the fact that everything actually has to run quite smoothly in order for the glider to be okay for deployment. Okay, so going forward, I hope I'm not going too far over time, but Hank was actually just talking about this before, so I'm jumping on board with that. We need more technical, I guess, knowledge, or, we need to be able to deal with more advanced repair jobs. So I think all Slocum G3 users have been having issues with the HD pumps, and servo motors are always a problem. So we need, additional training going forward with this, or just, more communication within the group, because people are working on these things. So yeah. Unsolved problems. So the problem that I've been having lately is the ballast stretch slocum. It's perfectly ballasted in the pool. The pool is very calm. The roll will be, plus or minus 1 degrees. And then when it's deployed, it will have a consistent roll to starboard side between like 5 to 7 degrees. And I can't work out what is introducing this list towards starboard. So if anyone has any suggestions or wants me to explain further, we can go through that. Yeah, that's me.
Great, Fiona. Thank you very much. Any questions? I don't see any popping up. Anybody want to chime in a question real quick or comment? So
Fiona?
on your, go ahead.
Quick question. I've had that sort of same problem on the roll. But I realized it wasn't while it was diving. It was only at the surface when the air bladder was inflated. Are you also having the roll while diving?
Yeah, I usually output data during the dive from the roll, just so I can monitor this and complain to my group that this is constantly happening and I'm not sure why. So it's I wouldn't know on the surface, but for sure during the flight.
Interesting. Yeah, let's talk some more offline about that problem. That's interesting. I was really worried that the roll at the surface would cause wings to break, because in high sea states those things get ripped around pretty bad when you've got 7 to 10 degree list.
Yeah.
On your long endurance missions, what's your biggest challenge as far as completing missions? I mean, do you have like a lot of biofouling? Is it mechanical? Is it other?
So biofouling's not an issue for us because the water's
Yeah,
so
wouldn't
cold.
be, right? Yeah.
And we consistently are diving down to 1,000 meters. So these are the cleanest gliders you've ever seen.
Yeah.
I would say, so the slocums are still really new. They're fine on their first deployments, and then on the second deployment, I find that you start getting the wear of sensors that you weren't really aware of. So there'll be, I think, in the cold conditions, there's more stress on the air bladders. There's additional corrosion on the ring to the air bladder. There's also, it seems to be more wear on the, do we call it a bellafram? The HD pump bellafram. So there are those issues. The biggest issue for us is just battery use. We don't have options to go and pick it up if it's dying. So we need to be really strict the entire time. So there's a lot of stress associated with that. But we have a really good group that we can share the stress with. So
Excellent. Thank you very much, Fiona. Great operation and great lab. Thank you.
Thank you.
Okay, we'll move on. Karen Dreger is our next talker from Skidaway Institute of Oceanography at the University of Georgia. And Karen, please take it away. And I do see your full brief. Yep.
I will be talking about what's in our Skidaway garage, and I'll start off by saying that we have a lot of gliders, but they aren't all ours, and I'll get into that. Skidaway is where the Socorro Glider Observatory is housed, which consists of 4 PI institutions and 2 additional partners, where we all collaborate on Socorro-funded missions. We share our assets and we share piloting responsibilities. Sometimes we'll share batteries between various labs. When someone has ordered some, but there's a backlog and they need to get out to do a mission, we've shared hull sections between our universities or partner groups as well. So currently in our glider lab, we have G1 and G3 gliders. We have a G1 with a 100-meter pump. That's Plasia, and that's owned by UNC. Salacia is a 200-meter pump, and she's owned by NC State. On temporary loan for a couple-year project, we have USF Murphy, which is a 1,000-meter glider. And then we have Franklin, who's the Socorro-owned glider. So the observatory owns the glider, but it always lives at Skidaway. And then Skidaway's own glider, Angus, is a G3. And soon to be coming to our lab will be a new G3S, which will be a brother or sister to Franklin, which will be owned by Socorro. And so in our lab, we also have, we have a lot of gliders. We have a lot of different operations, but we have spare parts like some of the other labs have mentioned. We have a spare Seabird pump CTD specifically to minimize the downtime for calibrations. So we'll send a calibrated CTD and a science bay up to Teledyne Web, and they'll swap it out, send us back our science bay with the already calibrated CTD we had, and we can continue doing missions while that old out-of-date calibrated CTD is off being calibrated. That cuts down our downtime of not being in the water. We also have a spare buoyant 200-meter buoyancy pump for the G3s. And again, that allows for servicing, keeping our gliders in the water and not having these big chunks of downtime while we're waiting for parts to be repaired or serviced at the manufacturer. Because we have so many different gliders that come through our lab, either living with us permanently or just stopping by temporarily, we've set up what we call a super freewave. So we leave one freewave box plugged into our dock server, and we've programmed that one box to talk to all the different gliders in our lab. That's just nice that we don't have to constantly go over and find the right freewave. We're able to just switch from glider to glider without having to make any changes because the freewave will talk to everybody. Again, we have quite a few partners for our secure missions. And so we have a pool of about 19 pilots from 5 different universities with varying levels of glider knowledge. That counts PIs that will pilot, technicians, students, interns, and part-time employees. So we'll post a schedule a week to 10 days out with a specific person who's on watch and a supervisor for that day. We utilize Slack to share messages. Whoever is scheduled to be on watch is the one and only person who is at the helm, who will be sending commands to the glider should it need manual commands during its mission or if it aborts. Other people can log in and watch, but this reduces any confusion as to who's going to talk to the glider. We also do post mission handoffs or post watch handoffs every day. So we have a status of how the glider's performing, what's been happening. So when we have our pilots cycle in, maybe they haven't piloted in a week or so, they can read and catch up on what's going on with the glider. It also serves as a nice record of any issues or problems that the glider is having during its mission. Our lab is broken up into 2 different areas, 2 different spaces. We have a dry lab and we have a wet lab. This is an image of our dry lab. Our tables are all static, so they don't have wheels and don't move around, but we have bench space to be working on 2 gliders at a time. We do have a sink in our dry lab should we need to wash or clean anything. This is where our dock server is housed. And then we have our wet lab space. We have what's called a floater tank. It's a collapsible tank like some of the other groups have. So should we ever need to move it or want to take it somewhere else to do our ballasting, we have that option. This room, again, has 2 benches for working and operating, and then a sink as needed. We have large tanks opposite this back wall. It's what the giant green hose in the back of the picture is. We collect seawater from offshore to use in our ballast tank, hold them in these holding tanks in the room next door, And then as we need to change out our tank water, we'll pump it in through that green hose. Our glider tank isn't super big, but it's big enough for our glider. We can do a full pitch H moment, even with a glider with an extended bay. One of the big issues that we have are pesky remoras flying in the shallow coastal waters off of the eastern US. And so ways that we've overcome them is limiting the surface area that they have to attach. And so we have these kind of white colored suits that we put on our gliders. They're made by a local seamstress. Each glider has its own suit based on the science sensors it has that are cut out so we can get our data, but again, maximizing coverage so that the remoras have very little places to attach to. Another way that we circumvent the remoras is by using the mesh netting that you'll see on like scuba tanks or tanks in different labs that we just stretch over the holes. Again, this just limits the smooth surface area for those larger remoras to attach that then weigh us down and prevent us from surfacing, which causes lots of problems. If you don't surface in time, then you blow your weight and your mission is over. Something else that we've done at Skidaway is we've adapted and made our own lifting veils in-house. This is the example of one of two different styles that we use. We call this the shark fin. This allows for a glider that has a stack-on bay or a ADCP payload bay addition to the glider to be lifted up but stay level because of where the curve of this is allows the glider to hang at the center of mass. They're really great for deploying and recovering off of large vessels. And this is the example for a normal glider with no additional bays, just a half arc kind of lifting veil. Other things that we make in-house and that have come in very handy is we make our own glider carts. Part of the reason we make these spare carts is we'll send them to our friends along the coast who may go out and recover a glider without us. So they'll just have a glider cart stashed in their warehouse, and then if we need an emergency recovery or a planned recovery and we can't send one of us, they already have a cart to put the glider on. This particular glider cart has a stronger base in the back, that triangle shape. We also have another version in this picture. Those regular peg legs, kind of like the standard carts, those actually will collapse down, so then you just have the wheels, depending on what vessel you're deploying from or how you want to operate. So that's the nice thing, that we've had the ability to make extra carts. Extra carts are also nice to have just on the bench when you're wanting to work on one section, but maybe have some more space, or if you're working on a glider that has extended bays or additional bays to really get in and work on one. It's easier just to move the whole aft section or the whole forward section to another cart to free up some space. And so before I take questions, I'll pose two questions to the glider community that our lab has struggled with recently. One of them is any recommendations or tips for keeping gliders safe during transport. We've recently had some bad luck and really rough rides for our gliders. We've had the little buckle straps break off. We've had the gliders slide back into the back of the crate and kind of damage the digifin. So I'm open to any suggestions to make it more secure when we're shipping our gliders. Anyone have good shippers or companies that they would highly recommend? We're open to those. Or if anyone's had very bad experience with a particular company, happy to avoid those. And then the second question I'll pose to the group, something that we'd like to do better or find a better way to do it, is how do groups who have multiple pilots handle information management, specifically with file changes or MA file edits during a mission across different operating systems and people in different locations? Do you have a good method for a file repository that works so that individual pilots aren't necessarily manually editing all of the files or making file changes, but there's already made files stored somewhere that they would go and grab. We've occasionally had issues with different text editors adding encoding or different things, and then the glider can't read the file and gets confused and aborts or ignores it for silly spaces or things that we weren't anticipating. So those are my 2 questions to the glider community, and I'm happy to take any questions from the group about operations at Skidaway.
I think we got one from David. Slide with the lab plus gliders. One fin had remora netting on fin. If so, thinking they go after that part as well at times, i.e. stuck fins randomly. So
I don't know that we've
sense?
had any issues with the fin. The netting doesn't cover the digifin part that moves. It's just
Right.
the part of the digifin that is static. Or we
David,
have tried placing a small piece of the netting on the part that moves, but we do cut it down and more or less glue it on so that the fin can still move freely.
does that help, David? Does that answer your question?
Yeah, there was the one picture, it looked like it had some black netting on the fin. I couldn't really tell what it was.
It would have been the same brown netting that's on the glider that we pull over, just a piece that's cut out.
Okay.
They really like to attack our gliders, and they will find any inch they'll attach to the wings. They will attach to the tail, even though they're kind of hanging sideways. They are very lazy and look for free rides.
Karen, sorry to, yeah, hopefully that answers David's question. I have I'm so glad that you brought up the issue of editing files, because we are living in the year 2023, and yet we still have these text-based editing, critical mission files that we're uploading and downloading, and like everyone's presented today, there are so many people in the laboratory that are working on the piloting simultaneously. And I don't have an answer, but I have an idea of what would seem like a pretty simple programming task, and that is to take the top 10 files that we're all editing on the Slocum platforms, granted, and maybe we need to pose this to manufacturer and make it so that we're not using a text editor, but we're just using drop-down menus. And every time that you save that file, it goes into the database automatically prior to being uploaded to the glider. It seems so simple to take the human out of the loop such that there are no more syntax errors. And if, as a glider group, we can move in that direction, I think it'd save a lot of people from a lot of time. And if anyone has that already, maybe you could share it with us.
Okay, very good. There is a comment that that's a hidden feature in Gandalf, but we can have those conversations in Slack and keep moving. Thanks, Hank. Thanks, Karen. Great, tips and tricks that you're using there, as well as throwing out some questions for the community, and hopefully you get some feedback on that. And there is from Haley here. For transport, we usually wedge some high density foam blocks in the crates, and we've used something like the shock watch mentioned above during shipping. Okay, and there's a comment here on Ocean GNS. I want to keep moving here to make sure we allow time for the rest of the speakers. So keep the dialogue going and in the chat session, and we'll move on to our next speaker, who will be it's both David Aragon and Brian Buckingham from Rutgers Center for Ocean Observing Leadership at RUCOOL at Rutgers University. So go ahead and take it away, David and Brian. I see your slides. Go ahead.
Yeah, I'm not picking up on the audio, Brian.
Yeah, if you're talking, yes, we're not picking up the audio. I see your mouth moving. I don't hear you. So let's see. Now. I'll tell you what, Brian, keep working on it and I'll hop over to Uchenna and see if that's working. See if you have to reboot or anything, and then we'll come back to you. How's that sound, David? Or Brian, I should say. Okay, Uchenna, are you ready? And then we'll go ahead and we'll get back to Brian and see if we can resolve that.
Can you hear me?
Yes. Yep. We see you. No slides yet, but yep, we can hear you.
Okay. Wow.
Hey, Bill, you're also muted.
Thank you, Nick. I'm sorry. Did you hear me introduce Uchenna?
No, can you do it one more time?
Okay, yeah, thanks. Sorry about that. Uchenna is Nwanko is at the Geochemical and Environmental Research Group, GERG, at Texas A&M. And he just recently came on board there, replacing Dr. Kerry Wilden. So, Uchenna, take it away, hopefully.
Hopefully. Let's see. Oh, damn it. It's not letting me share my screen. I must have facing some technical difficulty here on my end.
Okay.
I can
Well, keep
present
trying.
his slides if you'd like. He's emailed them earlier.
Yeah, go ahead
Is
and
that
present
okay?
the slides, Cody. Thank you.
Let me send the updated slide, if you don't mind.
That's fine.
Okay.
Fruity, do you have Brian's slides or no?
No, I do not.
Okay. In the interest of time, maybe if we can just use the slides that Crudy has. All right. So. All right. Crudy, can you just pull up the original slides if that way we can get moving?
Sure.
I just sent her the new one.
Sorry. I'm still not seeing anything hit my inbox, so I'm gonna go. Oh, never mind. Sorry, guys.
Got it?
Yeah.
Okay.
Okay, good afternoon, everyone. My name is Uchenna, and I would say I'm pretty new to glider and the glider community. So as Bill said, I recently joined Texas A&M, GERG, and over here we have Dr. Steve DeMarco and Sakib Mahmood, as well as Dr. Anthony Knapp. So Sakib Mahmood was the guy responsible for our glider lab and every glider operation. So I'll be working with him and assisting him. Next slide. Okay. So this is the GERG glider lab. We have two sections. The front end is where we have the glider lab, essentially for the underwater gliders, and it's about 250 square foot. In there, we house uh, four slocum gliders. Two two of the slocum gliders are have deep pumps, while the other two have shallow pumps. So this glider lab was established in 2014, and over the years it has progressed. And as we continue, I will show the gigantic ballasting tank in the lab. Next slide. Okay. So on the left top image, we can see the frame for picking up the gliders, and you can see a glider there on the cart and on a working table which has wheels on it. So this essentially, the table essentially helps in moving the gliders around the uh, the glider lab without stumbling and also with little effort. So if you look there, you will also see the previous ballasting tank was really very small. But then on the right image, you will see the new ballasting tank, which was purchased in 2019, and it's used for ballasting. And we actually use salt water in the ballasting for ballasting because of the region where we are located. We also see a couple of uh, uh, other facilities there behind the ballasting, the big ballasting tank. You can see we have a cabinet there, and we also have other cabinets for storing different parts of the glider. And if you look on the right side of that image, you will also see a box there. So that's actually helpful for transporting the glider in during retrieval and deployment. Did anyone say something? Okay, next slide. Okay, so we also ensure we follow several safety protocols. And you see on the left image, you see hard hats. These are usually very useful in cases of ballasting. We don't want to expose any of the staff to hazards. Then on the right side, you could see a work desk, and this is actually one of the benefits of the space in the glider lab because we have huge space. We could also do some office work there. You could see the office desk, and we could also see the board there So the board is very useful with regards to keeping records to certain information about the glider. So like I said, we have 4 gliders. So we try to partition the board into 4, and we put some information there. This is a way of having the information readily available as against whenever you want to extract the information, as against pulling out your computer and checking for or searching for information on your computer, or looking in a particular cabinet for um, for the information on the paper. So the whiteboard here is very useful for easy information retrieval. And you could also see that we also have this table or desk there, which is also on wheels, so which essentially helps in moving the tables around easily. Next slide. Okay, so glider challenges. So this is the Texas shelf, Texas Louisiana shelf. So on the left image, you see some plots there depicting some features on the seafloor. So this actually poses a danger to the gliders when they dive, especially when they go too close to the seafloor. So we try to, as much as possible, avoid getting pretty close to the seafloor. Then on the right image, you can see different mesoscale features, right? So the Gulf, we have the loop currents and then the loop current eddies. So sometimes when gliders are deployed, they get caught up in these strong mesoscale features, and that can be very frustrating to a glider pilot. Fortunately, we can only hope that your glider is not does not get caught in a strong current. Next slide. So Karen already discussed this. So we have challenges due to remote fish, which essentially can mess up your glider diving and rise or surfacing. So GERG also uses nets. So you can see the front and the back ends of the glider. We cover with net to prevent remora from sticking to the gliders. So next slide. So yeah, this is a pretty short talk. Like I said, pretty new, and I'm looking forward to a first glider mission, and hopefully uh, get to meet and know some of the glider community. Thank you very much.
Thank you very much, Uchenna, and welcome as well to the community. And your work will get busy as the hurricane season approaches, so which isn't always that far away. So I'll tell you, in the interest of time, since we had some technical difficulties, we'll go back to Brian. Please drop any messages or questions in the chat session, and Uchenna can monitor those. So Brian, thanks again, Uchenna, and Brian, are you ready to try again?
I'm ready. Can y'all hear me?
Yes, we can hear you and we can see you.
Wonderful.
Okay.
Ready to try again. Thank y'all for y'all's patience as well. So, are y'all able to see my presentation?
Yes, we are. And hear you.
Great. Excellent. So, hi, I'm Brian. I'll be speaking about RUCOOL's glider facilities as well as operations. So I want to give a shout out to Hank Rolfess because Dave really liked this 5 stages of glider operations. Today I will be mainly talking about points 1, 2, and 4, preparation, deployment, and recovery, just a brief summary. But I think it's important to highlight going from step 5, reintegration, back to preparation. And every glider deployment is different, whether that's a new environment we're flying in or a new hardware issue we encounter. So I really think it's important to take those lessons learned from those missions or hardware issues and be able to share those lessons with the community and reintegrate them into our everyday glider ops. Also, want to give a quick shout out or give a yeah, shout out to Dave Aragon, because he put a lot of humor into this presentation, so y'all can thank him for that. So here at RUCOOL, we operate two main physical spaces for glider operations. The first is the main lab, which is what I just moved into right now. But in our main lab, we have two benches, seen here, which are able to hold two gliders separately. Some noteworthy things about these benches is that they have tool drawers on each one, as well as this magnetic strip holder to hold tools. Each bench has its own copy of its own tools, and this is to help have technicians simultaneously working on gliders at the same time, so you don't have to share tools and possibly slow things down. Additionally, in our main lab, we have a electronic lift on an I-beam across the middle, used to help get the gliders on and off the tables. Very helpful. We have in the back here a scales and ballasting station. Back on the wall right here as well, we have a fastener organizer, so we can have different sizes of fasteners and be able to easily find them. But also worth noting, in our lab, we like to have specific drawers dedicated to different gliders, so that when you have a glider on a bench, you can grab that drawer, and as you're disassembling the glider, if you take parts out or fasteners or sensor caps, you're easily able to keep track of them, so they don't end up in a random place on the table or in a different spot. Additional things to know about our main lab: we have compressed air as well as a vacuum functionality built into the building itself, which helps with ease of access, and you have a near limitless supplies of compressed air. Our second space that we operate here is what we call the seawater lab / ballasting room. Here it's kind of like a 180-degree picture. But also noteworthy things about this room is that we have a bench similar to what we have in the main lab with its own set of tools as well as glider storage racks, as you can see here in the back. And then again, turning about 180 degrees from behind this bench, you would be able to see the ballasting facilities. Another noteworthy thing about this room is that we have a titration station set up specifically for running titrations to help calibrate our optode sensors. And something I kind of both of these rooms have is these stands that we built in-house for helping to hold our aft sections, as well as a pump or possibly payload bay from the gliders, so that instead of working on the cart, which can get kind of cramped, you can take those pieces off and then be able to work on them in a more isolated setting. Onto our ballasting facilities. We have about 1,000-gallon seawater tank filled with seawater collected from the nearby coast. For our ballasting tank, we have another electronic lift to help get the gliders in and out of the water, as well as these two arms that can swing over the tank to help hold our ballasting scale so we can do a ballast reading. Also, nearby the tank, we have our Seabird 19 CTD to cross-compare with our glider CTD to make sure they are in agreement. Another nice feature that we have in this lab is that there is a freshwater rinse hose right next to the tank. So when you take the glider out of the tank, you can just spray with fresh water to clean any salt water you have accrued on it. Another kind of cool thing we have are these little carts, which are very convenient because you can use a lift, load the glider onto the cart, and then instead of having to pick up the glider cart from the back handle, you can simply wheel them around the lab. So after ballasting and doing a final seal and doing some functionality checkouts, we like to do a compass calibration outside. We like to use a aluminum gantry, such as this one. This is a photo from our glider camp. It's very convenient. We wish we have two so that we can have one inside that you could help to lift gliders up with as well as move around the lab, but alas. So after doing a compass cal, final seal, gliders checked out, we're good to bring it down to a dock or a boat to deploy. So how do we transport our gliders to the dock? We have a Ford E250 van, utility van. That's very has great utility. Here is the image of the inside of it. With the cargo space provided from it, you are able to fit a maximum of 3 gliders into it if you're really motivated. But for typical deployments, we would only carry 1 along with possibly the Seabird 19 CTD or a small CTD rosette for water sampling, as well as some Pelican cases for the boat. Which brings me to the next thing. Here at Rutgers, we'd like to have these, what we like to call glider lab in a kit, or as listed here, we have a Grand Cayman kit or a Little Cayman kit in Pelican air cases, so that in the event we need to, say, fly overseas for fieldwork or drive somewhere far, we're able to throw this into the van or check it as a bag, and then we should be good to go. Things that we like to pack into these are a spare vacuum pump, additional or free wave equipment, such as a spare antenna or in the free wave itself, laptop, consumable items such as chem wipes, O-ring grease, spare O-rings, and things like that. Typically, with our experiences for the Grand Cayman kit seen here, because it has more stuff, when you check it, it'll typically be pretty heavy, so you can accrue additional costs by checking it with airlines. However, the Little Cayman kit we typically carry, or also carry, will usually fit within that 50-pound weight. Something that Dave wants me to highlight about this Little Cayman kit is the vacuum pump seen right here, which is noticeably smaller than one seen in the Grand Cayman kit. It is awesome, very compact, and it may pump slower, but it works nonetheless. Also worth noting, for any international travel, we always like to pack a voltage transformer because we wouldn't want to fry any of our equipment by accident. So as far as boat activities go, Rutgers operates 2 research vessels. One is located in northern New Jersey, slightly closer to Rutgers. And then the other one is located in southern New Jersey at Rutgers' field station. The one in New Jersey from Rutgers that we most often use is one called the RV Rutgers, which is seen here in the bottom right photo here. Something we really like about it is that it has a landing craft design, which is great for putting this ramp down, and then you're pretty much at the water level as far as being able to deploy or recover gliders. It's a 36-foot Munson aluminum hull, so it's a little small, and it doesn't do necessarily well in chop, but again, works nonetheless. So things for our lab that we haven't quite 100% worked out. As I talked about, we have a Ford E250 van. We're actually looking to get a new van because it's a bit old. It still works, but it's a bit old. So we tried shopping around, but with a similar Ford model, but unfortunately, because of supplies, we weren't able to find any. So a solution to this, or a possible solution, will be to try look at possible or Dodge vans next for similar cargo space. For Rutgers, our southern field station dock has a tendency to be filled in with sediment, as well as have a limit to only having a high tide or being capable to put boats out during high tide. So that's something else that we have to deal with. More recently, or fairly recently, we're starting to begin to heavily rely upon contracted boats. So even though Rutgers has our 2 research vessels, they may not always be available. They may be going or participating in a different project. So we have to often call around along the coast of New Jersey or the nearby states to look for vessels that would be willing to take us out and then do a glider deployment or recovery. One thing about that is that not all boats are the same, and so we're not often taking the same boat out every single time, although it would be awesome if we could. So dealing with the different boat designs, whether that be a higher freeboard or a different configuration, is something that we're working with. Additional item that we're finding is that gliders are starting to get heavier and more awkward. Awkward sensors such as the AZFP, which hangs below the carts. It makes it harder to deploy off the carts. You would have to take the glider off the cart and then deploy into the water that way. Because they're getting heavier and bulkier, it's getting harder and harder to do things such as small boat hops, where you can simply put the cart over the side, reach over to the side, and then pull the cart or the glider up. So possibly finding boats with equipment such as cranes or davits would be a nice solution to this, but something that we're starting to encounter more and more. Also, as far as glider storage goes, I showed a little bit of that in our seawater lab, but we're starting to find that maybe that's not the most optimal way to store gliders. So we're starting to have gliders on the ground or in other places in the corner of the lab, which can possibly become a tripping hazard, and I don't think anybody wants to trip over a digifin or a radon fin. So with that, I conclude my presentation, and I would be happy to take any questions anyone has.
Yeah, I think we're right at time. I don't know if people can stay on or not, but thank you very much, Brian. That was very comprehensive and really appreciate that. If anybody wants to, any quick questions, real quick, I'll leave it and then I'll kind of wrap up and it'll only take me a minute or so if folks could stay on for a minute. Okay. First of all, this great briefs from the 6 presenters, it was awesome. And the idea is really to help foster the collaboration across the community so people can see what other people have. And if you're a one-off just starting up, you can see what it takes to spin up, or regionally you can look around and say, okay, who has capabilities that I might be able to leverage and work with those folks. We had folks from Alaska today, from the Mid-Atlantic, Southeast Atlantic, Canada, Europe, so we Gulf of Mexico. So we really covered regionally some good areas. I want to continue this into, because right now we have Dan Hayes from Cyprus, Jack Barth from Oregon State, some OI folks, and James Pegg from Canada that also are willing to do this. I want to continue this theme on our next webinar. So I probably won't let it go 2 months, maybe more like 4 to 6 weeks, just to keep this fresh and moving. And I think it's awesome to foster the collaboration and keep it moving. So Slack, please use Slack to further communicating with these presenters or with other folks. It's becoming the tool. I really think, that moving forward, and we can help, refine that, add channels, get recommendations from you as the users. But, that's, I think the collaboration tool moving forward. So any really quick comments from anybody? I really don't have anything else. I just, again, want to thank the speakers, but does anybody have any quick closing comments?
Yeah, Bill, this is Carl.
Yes, Carl.
Yeah, so anyways, Kevin Martin and I finished up the maritime, uncrewed maritime sessions in October, November timeframe. And I just wanted to thank all the people, the UG2 members who were part of the group that did presentations to us. And I won't name them all, but we had 3 representatives from Woods Hole, 2 from NOAA AOML, 1 from Rutgers, 1 from GECOS, 1 from Alaska-Fairbanks, and we actually had 1 from the Scottish Association for Marine Science. So anyways, they went over really well. Not one of the presenters just wasn't enthusiastic. They were all very enthusiastic, and they helped out a lot. Our kids really enjoyed it, and hopefully they'll all consider doing it again next year. Thank you.
Yeah, great shout out. And Carl and Kevin are from USM, and they just had finished up the tier 2 level training. So
Yeah, and the ads, Crudy put the ad on for on the UG2 site for tier 1 coming up in March.
for future training, definitely.
Yep.
Okay.
Okay, thanks, sir.
And thank you, Sakib, for your comments. And I know everybody's got to get going. So thanks again, and we'll bring up the next. I'll be putting out information for the next webinar coming up soon. Thank you all.
Thank you all.